So I can use an interesting trick to invert the Burrows-Wheeler transform back to the original string, because the Burrows-Wheeler transform defines the last column of my Burrows-Wheeler matrix, and I can easily reconstruct the first column, and then using those two, I can work backwards to find my original string. But how does this help me do fast pattern matching? So let's say these two queries are what I want to find. It turns out that I can't only keep track of the first and last columns, I need to keep track of a few more things. So specifically, let's say this is I, which is the row number. So this is row 0, row 1, row 2, row 3, row 4, row 5, and row 6. I have to also keep track of this last to first mapping. So the last to first of row I. So last to first of row 0. The last item in row 0 is A1, and it appears in the first column in row 1. So in row 0, so when I equals 0, the thing in the last column appears in the first column in row 1. So last to first of this row is 1. Here, the thing in the last row and 1, the thing in the last column and 1 appears in the first column in row 5. So this would be 5. Here, the thing in the last column appears in the first column in row 6. That's 6. In this row, what appears in the last column appears in the first column in row 4. What appears in the last column here appears in the first column in row 0. And then A2 appears in row 2. A3 appears in row 3. So again, I have to pre-process this additional piece of information. Now, how can I use these things to do rapid pattern matching? So given a query, I can actually search for it backwards. So let's take the query AN. I can start with my top possible row as here, and my bottom possible row as here. And remember that in my original Burrows-Wheeler matrix, all rotations that started with the same prefix were clumped together. So if I can get top to point to the first rotation that starts with my query, and bottom to point to the last rotation that starts with my query, the range between top and bottom is exactly all instances of my query in my original string. So starting with a top pointer at the top and a bottom pointer at the bottom, I'm going to search for my word backwards. So in this query, I'm going to look for the first instance of n and the last instance of n in the last column. Those are these two instances, here and here. Those happen between columns. So the last two first of those is 5 and 6. So I'm going to shift top to be 5. And I'm going to shift bottom to be 6, which it already is. And now that letter is done. So now I'm looking for A between this range in the last column. So A appears in this range in the last column here and here. Those are positions 2 and 3. So top goes there, bottom goes there. That one's done. That exhausts the last character that I was looking for. So that means that A2 and A3, these are the two instances of my query AN. That means I can go map these back to my original sequence, because remember, these are just the rotations of my Burrows-Wheeler. These are the rotations of my original string. So I can map A2 and A3 back to their original positions in the original string, and that tells me where AN must have occurred. Let's try NA. So I start with top at the top row, bottom at the bottom row, and I'm looking for NA, but I'm going to do it backwards. So I start by looking for all instances of the last character, A, as it appears in this last column, between top and bottom. So the first instance of A is here, the last instance of A is here. Basically, I'm going to jump to top, going to row 1. So I go last to first, row 1. top is now pointing here, and bottom is going to point to row 3. Because those were the two instances of A in that column. So A is done. Now I'm going to search for N. So N in this range appears in the last column here and here. So these are positions 5. So top moves to position 5. And bottom moves to position 6. There we go. Now that character is done. Now my string, my query string is done, meaning these two positions tell me where this query existed in my original string, at N1 and N2, which are these two positions in my original string. Let's try one more example. What about NaN? How will this work? So again, I start backwards. Oh, I start with top, pointing to the top row, bottom pointing to the bottom row. I start at the last letter, and where does N, the last letter of my query, appear in this range in the last column? It appears between this point and this point, which correspond to 5 and 6. So top moves, so the first position is 5, the second position is 6, so top goes to, or sorry, the first position is 5, the last position is 6, so top moves to 5, and bottom moves to 6, so it stays where it was. Now the first letter is done. Now in this range, I look for A, the next letter going backwards. In this range between top and bottom, A appears in the last column, here and here. So the first instance is here, the last instance is here. So top moves to 2, and bottom moves to 3. Now, in this range, I look for the first and last positions of N. So between here, when does N show up in this range? It only shows up here. So the first position of it is 6, and the last position of it is also 6. So that means the first position of N in this range, in this column, is here. So top goes to 6. And then the last position of it in this column is also here. So bottom also goes to 6. Now I'm done with my query, which means everything between top and bottom, which is only this one character, is where this substring existed.